for data ingestion, data flow management. So for each scenario, we might need to mention these. So it will be ideal if one person can take one scenario and then do this.
Hello. I'm not speaking anything.
Okay.
Yes, this is Janardanan Prajapati. I have gone through entire document. I have gone through the this question papers also, this question also, assignment question. But I'm not able to find the answer to streaming SQL architecture.
One thing
I'll
I'm
be able
going
to
to
do.
identify is there is one submit here. So in this, all these are there. If you just go through this, right?
Can you send the link, please?
Yeah, sure. So 7-day installation, install date retention. So like that topic wise, if you go, you will see most of it here. I haven't gone through it fully.
SQL.
So
that way white paper also gives a lot of information. But SQL streaming, that I'm having difficulty in finding.
let me give you this link. And which is the question you are telling?
Where SQL and streaming is written.
What are the ways by which streaming data can be read using SQL?
Yes. And about white paper, if you want, I can explain the white paper.
That will be nice. Briefly,
33 pages is difficult.
Yeah, I can explain the white paper. That is not an issue in layman's language, but I'll explain.
Yeah, then you can start with it.
But this questions is all about this white paper, or how is it? The assignment.
yes, yes. It is almost entirely from white paper. If you understand this white paper, we'll be able to solve these questions. Yes. Links are there, but generally when you go through the paper and you go through the questions, most of the things will be there. Only we need to elaborate little bit more on those points.
So like, how is it like you go to questions first and then try to figure out that, or like we go through white papers and then
Actually that's better. Once you like you start one scenario, you go through the all questions parallelly, and then you will be able to correlate these questions. Actually, I started today only, so I was able to correlate questions and this white paper.
So should I share screen and explain?
uh, yeah, please. I think yeah, at least you can elaborate on the white paper. So
Yeah. So in white paper, first topic is real-time and near real-time application scenarios. So you understand what are these, right? Real-time and near real-time. There is little bit difference. Real-time is basically within seconds. That is less than a minute. You need to process the data that is getting generated. For example, IoT devices, or maybe real-time GPS location of a car, usually those taxi services monitor. And near real time is wherever there is more than a minute delay. So that is, they are saying that it is near real time. Okay. So they have written something here. And then difference between batch and stream processing. So batch processing is whatever data is getting generated. You are first collecting it for some time, and after that you are processing it. While stream data is live data that keeps on coming, it is not stopped. For example, live match, cricket match you see live, it keeps on coming ball by ball. And batch processing is suppose the same match. What I'm doing, for every over I'm first collecting the data, and then I'm doing some processing on that. So
By
the time,
definition, sorry, just by definition, how we can distinguish between the batch processing and the stream processing?
so batch processing, we make batches. For example, you can say that suppose water is flowing. Okay, stream is flowing, suppose. So stream is continuous. There is no batches, right? But if someone fills tanker and tanker by tanker delivers that water to you, that is batches. So what happens? You are collecting the data, means collecting for some amount, then processing it. But when it is stream, you have to keep on processing without collection. You process it, pass it on, process it, pass it on, keep on processing.
Then the stream processing, we can think it is like a real time, but batch processing is
Yes,
not exactly real time, no?
batch processing cannot be real time.
It may be near real time, but it is not real time.
Yeah, at max it can be near real time if you are making batches of 1 minute. Otherwise, it is not real time. Batch processing, one example I can tell you, whenever there is ETL processing, means we are getting data from various data sources. We are adding those data to flat file, then those flat files are collected, and that is passed through ETL process. Means ETL tools like say data stage or talent tool or informatica, any tool. Okay, so what happens every day is daily data we process at one time. That process may take say 5 hours, 10 hours, or it may take even just 2 hours also. So that is 24-hour batch, one batch in 24 hours. Similarly, batch can be once in a month, once in 6 months, or for 5 minutes there is one batch. Every 5 minutes we are making batch and processing. So batch means it is not real time. Stream processing challenges. Stream processing challenges, obviously stream is coming on. It is keeping on coming. You cannot stop it. So the pace it is coming, you have to process the stream with that pace. That means you need big compute power, you need large stream processing power, or compute power itself, or storage also. Accordingly, if you are storing, then stream keeps on coming. That means you need large amount of storage. And so since stream is coming on, you need to generate analytics real time. So that kind of challenge is there.
Only one thing, what is the challenge for batch processing? This is stream processing as continuously coming, their storage we have to see, and they have to fine tune it because there is no stop and no batch kind of thing continuously coming. So there is a challenge for storage as well as computing capability. But what about the challenge for the batch processing?
So in case of batch, what happens? Uh, Typical example, if you take data warehousing, every day's batch comes, we store the data in data warehouse after processing, and data warehouse size keeps increasing or growing. Or in case of cloud environment, in this particular case, we keep on storing that data to S3 standard storage. And if we think that historical data is no more utilized, then we archive that data to Glacier, S3 Glacier. So challenge wise, I'm not sure what should be the challenge actually. Only thing is only challenge may be the
with respect to functionality, see, which is not required that you are storing for backing up or for long time storing, that is fine. But like for functionality wise, just like a continuously stream processing coming in with respect to computing capability, we have to increase, and fine tuning we have to do.
got it.
Those kinds of things in case of batch processing, how it could be? What is the challenge in that case? Because there may be some gap is there, be batch coming. Maybe it is enough for computer processor to manage and handle those things and all. But there also memory constant will be there, no? Anyhow, it may be some delay, sometime it will get, but still memory also may be there. But regarding the batch streaming, batch processing, there is no challenge mentioned here in this paper.
Yeah, I also think there will not be big challenges in that.
Right? In some cases,
And
we
that
cannot use the batch processing at all. For example, for fraud detection use case and all, they need the real-time data. So whenever we swipe a credit card, immediately we are getting a call telling we have swiped it right for a huge amount. So there is a real-time processing of the data happening. If it gets delayed, the money will be lost. So such
right. For example,
we need to go with the stream processing only.
yeah. For
So we can say
example,
that. So so then we can say that any applications which are critical for time, like any time critical applications, those those will not be the appropriate use case for batch processing, right?
right.
Correct.
Yes.
Correct. Yes.
Wherever you need real-time notification, in this example, as she was mentioning, you have to go for real-time streaming.
Right. Okay.
I did not get that. Okay. IoT related, yeah,
That is
temperature, yeah,
that
yeah, they have mentioned. So
that is
I'll
one of the
explain you.
scenario mentioned.
Okay, in this scenario, what is happening? Stream of records is going to Kinesis data stream. This server means nothing but whoever is generating. It can be an IoT device also. Means, for example, temperature sensor, which is taking the temperature every second or every minute, and that stream of records, that becomes a stream. Means every second temperature is getting generated and it is sent to Kinesis data stream. Kinesis data stream, what it is? It is just a database. You can consider it as a database which stores data in terms of shards. Shard is nothing but the horizontal partitioning of a database. So you can say it stores data in batches. One batch is called as shard. Okay, so it stores data in shards, and those shards we can make it to store data up to maximum 365 days. Minimum 24 hours it remains. Okay, so it is related to stream only. It passes on, it takes the data from the input, passes on the data to any processing thing, any compute. It will not pass the data to any storage. That is data stream property, kind of KDS property. It will pass to only for compute.
Kinesis, what exactly doing?
Kinesis is only storing the. It's like you can think of double mic somewhere.
Your voice is not clear, no?
My voice is not clear. Oh.
Once again, can you tell? Hello. Maybe.
Okay, so I was saying Kinesis data stream. Kinesis data stream is like a database. I can give you analogy what it is. So you can think of uh, water stream. Water stream flows. So here water stream is flowing from source of water to our water tanker or to some water location means some to somewhere where that water can be utilized. So water source can be, say, for example, underground water or uh, underground water tank, overhead water tank. From there, I'm delivering to, say, fire hose because I have to firefight. Fire hose is there is some pipe and system is built with every building where fire brigade comes. They put pipe, their own flexible pipe in that fire hose, and then water is started, and then they fight with fire. So that is fire hose. Fire hose is near the delivery location where water needs to be delivered. And stream of water, this kinesis data stream is like from the source of water to the fire hose, whatever water is flowing, that is part of kinesis data stream, you can say. So it is taking the data, storing it temporarily, and then delivering it to the processing application. Processing application may be, for example, in this case, it is AWS Lambda. It cannot deliver to any storage location. Processing application can be
Uh,
data fire hose also.
Janardan, a question here.
Yes.
So this Amazon Kinesis data stream will be responsible for data ingestion as well as data flow management and storage. Three properties, right?
Yes.
So data ingestion will be there, data flow management will be there, and data storage. So we can store data in this Amazon Kinesis data stream, right?
Yes, up to maximum 365 days. And since it stores the data, you can replay that data also. That replay feature will also be available.
Okay, because in first question itself they have asked about this data ingestion and flow management. So
Yes.
this service will be responsible for that
Yeah,
feature.
right.
Okay,
This
okay,
Kinesis,
okay.
you can store data after 365 days.
Yes,
More than
maximum earlier it used to be maximum 7 days, but now it can store up to 365 days.
in this stream only we are storing data.
I
Kinesis data.
said I said Kinesis data stream is like a database. It stores data in shards.
Okay.
And shard is nothing but if you partition a database horizontally, then that will be called as a shard. From very basics, I am explaining. Okay.
And
So
lambda is for processing.
Lambda is, you can say it is a program. It can be in any language. It is a program. You write C program, you write any program, Python program. You open Lambda is basically an application where you write any program. In this case, what they are doing, they will write put a condition, get input temperature. If temperature is more than 40 degree, then generate alert. That's all.
I can give an example on this.
Yes, please.
For Lambda. So for example, there are a stream of images coming from some source and we have to do some processing on that. So we can write like a small code in on this Lambda that we need the size of picture like this pixel by this pixel. So we can write a small code and this AWS Lambda, this is just a small example what it can do. So this AWS Lambda service, it will what it will do, it will crop those images of that required size for all the streams coming through this Amazon Kinesis data stream.
Okay.
Right, Janardan?
Okay, one thing I will clarify here. Lambda is something where you have written all the program, all the code. Everything you have written. There is nothing in Lambda.
As per our requirement, we can write a code.
Yes, you have to write everything what it is supposed to do. It will give you option which language you want. Go, C, C++, Python. There are so many options. You have to choose and write your program. Simple. Okay. Now next.
Why both side, left side and right side server they have drawn? Left side, left
Which one in this diagram?
Yes, yes. Leftmost and rightmost both server they have written. No, why?
Okay. They are saying server you can consider as a machine. Some machine or something, for example, IoT device. They
From
are
where
sending
this
the
result will
data.
be generated, right?
Yes.
This
Here the
end
result
will be
is
where this
generated.
result will be published.
Yeah, published or stored. Yes, right. So do not read it as server. You read it as input and output. Simple.
Yeah, correct. Input and output.
Now, to support these data streams, so there will be that Amazon Kinesis producer library, KPL, okay, and SDK will be there so that you can do some programming. Then Kinesis agent is there, okay, which will Kinesis agent means basically since you will be using different kind of applications to generate data. For example, in one case it will be IoT, in another case it will be thermometer, some again IoT. In another case it can be a database. Means there can be many type of sources. So for different sources there will be agents which will collect the data and send it to Kinesis data stream. Agent you can say kind of converter.
So Janardhan, then this like AWS SDKs and this agent, this Kinesis agent, this will be used for transferring of data from input that server to our this Amazon Kinesis data stream, right?
Right, yes.
Okay.
You can configure accordingly, means program configure what how to generate data, what will be the metadata of that data, and it is writing that okay you can fire this put records or put record. Difference between put record is one record at a time or multiple records at a time. Okay.
But this put record and put record query, where it will be written, it will be in server input server or Amazon Kinesis data stream side.
It will be in the uh, wherever you are doing SDK programming and sending data to Kinesis data streams.
This is
So this
something like an
SDK
API.
programming
You can say at input side.
input side, right? Because it is put, so we are forwarding this data to this Kinesis data stream.
Right.
So it will be input side.
Yes.
Okay.
It is something like an API that is exposed by Kinetics. So the provider, right, or like the person who is generating will consume this API to send the data to Kinesis stream.
Right. Okay. So next is when who will consume the data and how will consume. So for consumer, since Kinesis data stream will give you data, means you can read it record by record, then you can use Kinesis consumer library. Okay. And Kinesis data analytics, Kinesis data firehose, then Lambda also you can use, or you can integrate the glue streaming. But glue streaming you need to use. Glue, two types of glue is there. Glue one is that batch processing is used. Another is glue streaming. These are two different features of glue. So this way you can process the Kinesis data streams. Means there are ways how you can means data streams. You can say there are defined processes. For example, AWS Lambda can process, Glue can process Kinesis data streams, or you can say Kinesis data streams can give its output to specific applications only. It cannot give to everyone.
Whether this
Like
is a library API using that only you can do, or what is it?
so, KCL is library.
Where actually we use this library, it will be
On the output side of data streams.
okay.
For example, if you are programming in AWS Lambda, so there you can use KCL means APIs to read the records or understand the records.
See, when you are telling that we are programming into AWS Lambda, whether it is a processor or memory, where we can write, because we have to execute.
So AWS Lambda is a serverless compute.
That means processor. That is one type of processor we will be executing. Compute.
Right. So in Amazon AWS services, if you open, it will give you option AWS Lambda. If you type Lambda, you will open Lambda. A notepad type thing will open. There you select language and you start programming. And in that programming, you can use KCL.
Now you tell me, serverless means here what it is trying to say.
Serverless means you to compute you need RAM, right? And little bit of disk space also you need to read data, etc. But serverless means you need not to worry about RAM anything. You just write your program and execute it. In the background, it will take care of from where to get the RAM and from where to get the intermediate memory.
That means it is like a client server. Whatever I am giving the command executing, it is passing to the backend some server. Somewhere it has to execute means somewhere a processor memory.
It is actually having a processor and like everything. It is just that AWS is managing it and not us.
Exactly. It is fully managed by AWS. We have nothing to worry about.
Our request or command, it is taking and passing to the backend some server and all executing again give back us the output. Maybe.
Yeah, in the backend it is executing and giving us the output. You are right. Same way, Glue is also serverless. Only thing is, but still, in case of Glue, I have to specify how many number of workers should be there, how many executors should be there. I need to configure. But still, memory management, everything in the background, AWS takes care of. Okay.
This Lambda and Glue, what is the difference?
Lambda Glue is ETL integration basically.
Okay. The ETL is
and
there.
Lambda is
ETL.
Lambda is just Lambda is just to write some processing. That's all. Glue, even ETL workflow it can create. Means you can write multiple glue jobs and connect all those glue jobs using one separate glue job. So it is basically ETL integration. Like Informatica is, like Talent is, you can consider that way. And this one, these are internal, like fan out, fan in. These are fan out or fan in, basically data coming in and data, the speed at which data will go out. It is shard iterator means it is going through records that are stored in the shard. Get records, it is normal, you understand, right? Processing streams are data with AWS Lambda. Lambda is nothing but just like you open C++ and start writing program and start processing the data. Okay, latency, you understand what is latency. Latency means delay, or latency is basically response related. Minimize latency means minimize the response time. Scenario 2 for security teams, let us see. I'll explain here directly.
Just to add, right? I think we also have a question like what is used for data processing. So here data processing is done by Amazon Kinetics data stream and AWS Lambda.
No, processing is done
Lambda
by
is
AWS Lambda.
Lambda, yes. Processing is done by
Processing
Lambda.
is not done by Kinetic stream. Kinetic
Yeah,
is only
Kinetic
for
is
data
data stream.
ingestion and flow management.
Exactly.
Okay.
Yeah, it just processing. You can say that it is taking the records and passing it on. Only that much processing it can do. I think it cannot do any transformation. For transformation, you need data firehose.
Okay. So enrichment is by Lambda only again. Enrichment and processing.
Yes, enrichment. For enrichment, you need some programming. That means you need something like Lambda, or say Kafka also can do enrichment. Any ETL tool can do the enrichment because you can program it. So wherever you can have scope to program, you can do the enrichment. Okay. So in this case, what is the case actually? Whatever is the case, okay, data is coming from somewhere, and this somewhere can be Kinesis data streams also. Okay, stream of records is coming maybe from Kinesis data streams, or maybe from directly from the directly from sensor. It cannot come because Kinesis data firehose will not take inputs from the sensor. It will take inputs from the data stream. So one option is you store that data to S3, means you can store that in a bucket, or that is also delta lake, part of delta lake it can be, or you can store that data in Redshift. It is saying every 5 minutes, means it is making batches. It is not continuously storing in Amazon Redshift. It is making batches and then fanning out to Redshift. And then Redshift is relational database, but it is data warehousing database, so it is used for BI purposes. Maximum capacity of Redshift is actually in petabytes, 1 to 2 petabytes of data you can store. So,
So,
in this case, you
Meghna,
need that. So the why we are using this diagram to explain that Kinesis data firehose you have to use if you want to store that data either to data lake, for example, in S3 bucket, or to a database. Then you need Kinesis data firehose. The purpose of this diagram is this one.
But how is it actually saving directly to Redshift? Some processing has to be done.
It is integrated. It is integrated. You just specify the destination. You configure in data firehose the destination,
Whether
and it will do.
for storing into the Amazon S3 or Redshift, whether any script has to write or API call has to use, what is this? After Kinesis data stream, how it is going actually? Every 5 minutes you are storing to Redshift or Amazon S3, just
So
like
it is like you open the Kinesis data firehose from AWS console. There it will give you all the options. What will be the destination? In destination, it will specify like S3, Splunk, Redshift, or HTTP location, like this. Once you choose, then it will give you, if you want to make it in batches or random, something like that. It will give you options.
yeah, it is UI
well, these are all AWS product only, right? So they can easily integrate.
Yeah,
So it
you
will be
can
like
just
an
configure it. It will give you
configurations
configuration
only.
page. You need to not to worry about.
Correct. It should be like easily integratable with the AWS product. So you don't
Yeah,
need you don't need to worry much on the integration.
yeah, that is all UI part you can say. So the crux of this I explained you that you need Kinesis data firehose if you want to send the data to a destination, storage destination. Okay.
So Janardan,
And those
we don't need a data Kinesis data stream for this scenario. The data
Kinesis
file.
Kinesis data stream cannot send data to storage. So this server, wherever server is written, that server can be called as Kinesis data stream.
Actually, in this scenario, they had already a system where they had Amazon S3 and this Redshift. So what in this scenario they wanted something to process that to take data from the source and send it every 5 minutes. So that's why they have given this fire hose here, not this first option that Kinesis data stream. So they had already some hardware and they wanted some additional feature. And for that purpose, they have added this firehose since they had already S3 and Redshift, and it will be easy to send data through this firehose.
no, when I store to Amazon Redshift and when I store to S3. after Kinesis stream came and it come to suppose Kinesis data firehouse I am using to store either Redshift or Amazon S3. What scenario I should go for S3?
So
Redshift?
yeah, it's your choice. If you want to send data to data lake, you can send that. If you want to send data only to Redshift, you can send only to Redshift. If you want to send data only to Kinesis Data Analytics, you can do that. It is just an example.
That's
In this
okay.
yeah.
Yeah, it is mentioned that what is the difference Amazon Redshift and Amazon S3. Both are for storing purpose.
So
But
one
they are
can create tables. If you want to create tables, you can go with Redshift. As file, if you want to store, you can go with S3.
S3 just a repository, the infinite storage in the network. Redshift is proper database. Okay, you can consider S3 as infinite disk and Redshift as database. This much difference is there.
I think here we just need to understand what is the difference between Amazon Kinetics data firehose and Amazon Kinetics data stream. So data stream is used for sending to processing like AWS Lambda. So here data firehose is used for all integration with all the Amazon tools.
So data firehose will send data to storage.
Okay.
And 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 this data streams will send for further processing, for example to Lambda, for example to Kinesis data firehose. Okay. Next, I'll explain the diagram only, that will be better for me. What is here? I'm not able to see so small. Okay, server, source record, Kinesis data firehose. And then it is again S3 bucket, and from S3 bucket to Redshift. There is no difference actually. In this case, they are sending to S3 bucket, and then from S3 bucket, uh, Redshift loading data to Redshift. From S3 bucket, when you load to data to Redshift, there is command basically. Copy command is there. So yeah, there I do not see there is much difference. That is just one use case of how you can use Kinesis data firehose. That's all.
Janardanan, a question here actually.
Uh,
In this scenario, for example, if we have some processing like AWS Lambda or Glue, so it will be after this storage, like S3 or this Redshift, right?
yeah, you can
We
write
cannot
anywhere.
connect. We cannot connect directly from this Firehose.
Firehose to Glue, there is no integration, right?
but in between Firehose and the Amazon Redshift, their Bitbucket has come.
That is not necessary. You can directly send it to Redshift also. They are what they are doing. They are transforming the record, then uh, and they are writing various kinds of notifications also to S3 bucket, and then from there they are loading to Redshift. So that is optional actually. If you do not want that way, you can change it. And the data that is coming to Kinesis data firehose, they are storing as is to Redshift S3 again. So there are two parts they have made. One, the data which is coming, they are storing as is to S3, and that is mostly the part of data lake. So where data lake, we say that it is immutable storage. Whatever source data is coming, we store it as is in data lake. So one, that below path is for that, and the above path is you are doing transformation to data, and then you are storing that data to S3 bucket first, and then you are shifting that data to Redshift. And why S3 bucket in the intermediate? Because you want to do further transformation. So one level of transformation you tried doing to store immediately after Kinesis data firehose. Next, once you stored in S3, you further did transformation and stored data to Redshift. Okay. Any question?
So in this case, yes, yes. So in this case, this data firehose will be responsible for data ingestion and flow management, nothing else. Or
Yeah, it is data ingestion, right?
and data flow management, that's all. And storage will be here. So in this case, there is no processing being done.
But why for storing also Firehouse is responsible? So because it is only sending data to Redshift or S3, no?
Yeah, it will directly send to Redshift and S3.
Then for storing he is responsible. But
No, storage is being done by Redshift or S3, right? It is just sending the data to there.
okay.
Here, processing is done by data firehose, right?
So that depends what do you mean by processing. Yeah.
Because here it is some transformed record which is being stored in.
Yes. Yes. It can do transformation. Kinesis data firehose can do transformation. That level of processing it is featured with or equipped with.
What injection is doing here? Firehouse, what is the injection they are doing?
Firehose is sending data to S3 bucket. So that is all ingestion also, you can say. But ingestion, when we say word ingestion, that means from outside, means the ultimate input. So whenever ingestion you read, that you should consider from the outside. So from outside, you cannot send directly to Kinesis data firehose. In between, Kinesis data streams has to be there. So wherever this server is written, so that means it is Kinesis data stream or some AWS service.
Then Firehouse is not doing any ingestion.
No, it is not doing ingestion. Just input output. Elasticsearch is also a destination for data streams actually. I'll skip this. Okay, summary. Next,
What is the use of
preparing click.
Elasticsearch? And just a storage only, or is there any specific
Which one?
differences? Elasticsearch.
Elasticsearch, I think it is in memory storage for searching. I need to see
Okay,
what it is.
In Amazon, Elasticsearch searching very faster maybe.
Okay, yeah. Yeah, what is okay.
Okay, now preparing clickstream data. When you say clickstream, you have often seen that whenever you go to Flipkart, you click on many products, you add to wish list, you add to say shopping cart, and then you immediately come to Facebook and you find that all those advertisements are in your Facebook. So that kind of thing is called as a clickstream data. For data insights, since Facebook captured all your clickstream, so it generated insights for you, and it showed you advertisements related to what you visited. If you visited clocks, it will show you same clocks, for example, Titan wall clock or Ajanta wall clock or Oriva wall clock. It will show you all the same advertisements. So that is clickstream processing. Okay, so in this case, you can say data is coming to DynamoDB order database. So Dynamo order is getting generated to DynamoDB, and at the same time order can be sent to Amazon Kinesis data stream. Okay, and catalog can also go to Amazon DynamoDB. Amazon DynamoDB is basically a document database or a key value pair database. One record can store maximum 400 KB of data. So DynamoDB is, you can say, NoSQL database from AWS, and it is very AWS specific only. It is not it. Okay, I should not criticize. Okay, but it is very fast rate. It generates data very fast rate, very efficient. Okay, then all the three means this catalog, glue catalog cannot run without catalog because it has to read the data that it is getting. What are the columns? What are the tables? Okay, and Kinesis data stream also is giving data, DynamoDB also, all the three can give data to AWS Glue. So AWS Glue is kind of ETL integration here, and then it is writing data to DynamoDB. So DynamoDB actually, good property of DynamoDB is its tables can find out what are the changes to its data. For example, today if I added 100 records, tomorrow I add say 1000 more records, then it automatically generates a stream of changed records. That is called as DDB or DynamoDB stream. So those change records. So we need not to worry about the CDC capture. CDC capture is basically change data capture. Since it automatically generates the change data, and that change data you forward for to Lambda for processing, and again process data, which is kind of summary data or maybe some transform data or whatever processing we have done, again to DynamoDB along with its catalog, and it can either get further processed or that's it. Okay, and Lambda
This is Sage.
Lambda can
This is
send that data, DynamoDB stream data to SageMaker also for machine learning or model training model, etc. So SageMaker is basically machine learning or training models, all those things.
Exactly what is that? That is machine learning operation is doing in SageMaker, huh?
Yes, it is doing machine learning. It can implement all your algorithms of random forest or whatever algorithms are there. All machine learning algorithms
But
you
what
can run through SageMaker.
main feature of DynamoDB?
DynamoDB is just a database.
No,
Main
but
feature here being utilized is DynamoDB stream.
Redshift also database like this story. Huh? What exactly?
So
This
I
is
told you,
RDS or
okay, I'll tell you the difference. Redshift is a relational database. It is a data warehousing database. Okay, so relational database is different from NoSQL database. NoSQL database is DynamoDB. In Redshift, you can, though it is a columnar storage, but your record can contain any number of bytes. But in DynamoDB, your one record cannot exceed 400 bytes. Sorry, 400 kilobytes. And and this is key value pair or a document. Document means JSON. Either it can store a JSON record or it can store a key value pair record, DynamoDB. Okay, DynamoDB is very costly as compared to Redshift. DynamoDB can scale to any level to ingest data, means it gives you microsecond of response time. Whenever you need microsecond of response time from a database, then you need a DynamoDB. That is biggest advantage. And moreover, it automatically generates the change data capture in the form of DynamoDB stream. DynamoDB stream is nothing but changed records of a table. Okay.
DynamoDB is faster than this Redshift. Huh?
Yes, microsecond. You imagine microseconds of response time it gives. Automatically scales out. It is serverless. And in Redshift, so Redshift is not serverless. Though serverless Redshift is again introduced, but Redshift is a database, and you can choose storage like means you can choose node type like DC2, RA3, DS. Okay.
just maybe you can just brief on the catalog database, DynamoDB catalog database.
Okay, catalog. What is a catalog basically? You know, whenever there is a
Indexing.
flat file, whenever there is a flat file, you need to understand what columns are there in that flat file. Means what is the table name, what are the columns, or how to read individual columns. So that metadata of table and columns is the catalog. So DynamoDB catalog is basically it is storing your properties of the data. Simple. So it can store only the catalog which is being used by glue, because glue cannot run without catalog. All ETL tools need catalog. Okay, so glue catalog can be stored in Hive, glue catalog can be stored in DynamoDB, or glue catalog can be stored on maybe S3 also. I'm not sure about S3, but in this case, DynamoDB is storing the glue catalog.
So basically, the structure of the data which we are processing.
Yes, catalog is nothing but the structure of the data. If data is already structured, means if it is already in database, then you know the structure. You do not need a catalog. But when data is coming from NoSQL database or not NoSQL, because NoSQL also has the properties. If data is coming from the flat file or sensors, then you definitely need the structure of the data. Means you need something to explain you how to understand data. Otherwise, in first column some numbers will be stored, second column some names will be stored. You need to understand what you call first number, whether it is ID or it is something else, maybe order number, for example. Next column, is it first name, device name, or is it description? You need
Something coming
to,
from the screen.
yeah,
Screens, then it may not have the structure.
yeah.
Okay, you can continue.
Okay, so glue streaming, these are two different features of glue. You need to choose whether you are using glue or glue streaming. Glue is only for batch processing. Glue streaming can handle the streams. Okay, glue data catalog, I told you, when data is coming through flat file or something
Now,
where
one
data is.
first, actually, we saw that AWS batch processing. Now, AWS Glue, you are telling AWS Glue also batch processing. Then, what is this difference between AWS Glue and the beginning batch processing?
Actually, glue will, okay, batch processing is a concept where you process the data in batches. Glue is a tool that helps in batch processing. That will actually process your data. Okay. Now, CSV format is there, JSON format is there, ORC is there, Parquet is there, Avro, or any other customer defined format. So CSV you are already familiar with. JSON, which is DynamoDB format. JSON is where with each record you specify the column name, and ORC is object row columnar. So it is columnar format. Parquet is again columnar format, but it is more like a database where header will contain your metadata information of table and column, and footer will contain index information so that data can be queried quickly. Avro is basically row format where data is stored in row like Oracle database or any relational database, which is not NoSQL database like Redshift, because Redshift is columnar database. Even if it is relational, it does not store complete row in a block. It store columns in blocks. Since I'm working in this, so I'm using a lot of terminology. I hope it is okay with you.
Oh yes, if any query you'll ask.
Okay, now glue streaming. Now when we say glue is a tool which uses PySpark in the background. And PySpark is nothing but it uses Spark technology. And when we say Spark programming, there are data frames. So glue uses dynamic frames. Dynamic frames is not supported earlier, but now dynamic frames are supported. Glue 1.0 did not have dynamic frames. So dynamic frames is nothing but data frames. Okay. Data can come from RDD also, but mostly it supports the data frames. Glue. MSK is used for data streams. Mostly real-time data streaming. This Kafka, Amazon Kafka is preferred. Means managed services for Kafka. Since Kafka is open source, so Amazon uses it in the form of managed services for Kafka. Okay, DynamoDB I already told you. Data capture for DynamoDB streams. There is configuration, you can do it. Okay, Lambda can be used. Yeah, Amazon resource number, it is for every resource you create in AWS. That is not a big deal. So Lambda functions synchronously. So there are two options for Lambda to function. Lambda, whenever you run a Lambda function, it cannot exceed more than 15 minutes. Earlier it used to be 5 minutes only, but now it cannot exceed 15 minutes. That means any job you are processing more than 15 minutes, you cannot use Lambda. But if you want to use Lambda, you have to use Lambda in asynchronous mode. Mode means Lambda will initiate the job, then Lambda will die. Job will keep running, but Lambda will die. But in synchronous mode, Lambda will issue the job. Lambda will keep waiting for the output. Then it will do next row of
But
processing.
asynchronous does not mean it will die, no? See, generally it is like a I trigger one process, trigger other process. Thereafter that process will trigger other process. So everybody in a chain, one after another triggering, then only it is happening. In synchronous cases, all together trigger means everybody will be sync that way.
Yeah. So in case of synchronous mode, so what happens? One triggering other, then other triggering other. So everybody is in waiting state to finish in reverse order. Last last trigger will finish its job, pass the output to previous one, then to previous, till the start that okay, job has finished, now you can stop yourself. Right? That is synchronous mode. But in asynchronous mode, what happens? One lambda triggered and the lambda. So this previous lambda is dead now. It is not traceable. So that means if you are building stateful thing, then you have to store that state somewhere so that it can be read from other new lambda or new processor application or whatever you are writing or new program. So so wherever asynchronously you are using, you have to go for mostly stateless thing. Again, I used a lot of terminology. Amazon SageMaker and SageMaker service endpoint. Endpoint means where it serves. Means endpoints means where input is coming and where output is coming. Basically, in how it can be integrated to other services. Okay. So most of the cases it is API, SageMaker API, and in step functions, for example, step functions just call SageMaker APIs to execute the SageMaker functionality. Data inferring data insights in real time. Again, when we say real time, that means either you need to use MSK, means Kafka, or data streams you need to use. And real time means DynamoDB you can use because it gives you microseconds of response time. And real time means response you will get in less than a minute. So that is acceptable. Okay, please read it. Actually, I do not like reading a lot. Okay, scenario 4, device sensors, real-time anomaly detection and notifications. Okay, so here what they want to do is temperature, engine temperature. Okay, it is related to again temperature sensing. Hello? Hello?
Yes.
Am I audible? Yeah, meeting ended just for me or for everyone?
Yes.
Okay, okay. So they want to realize that we are free users. Yeah, I'm sharing screen. So now in this case, this particular use case, a lot of use of IoT side of services of AWS is being used along with Kinesis set of tools. So, so first icon is the sensor itself, sensor which is responsible for generating data. In this case, it is temperature sensor. And then there is device gateway. Device gateway means the device gateway is nothing but connection between the outside world to the AWS world. So gateway does just that. Okay, so that is called as device gateway. Then IoT core. When we say IoT core, that means basic functionality written to handle the IoT side of input. So all IoT inputs will be captured by IoT core. So IoT core is nothing but the, you can say, hardcore IoT side application. Okay, so IoT rules engine is again, it is related to rules basically. What is the related to data means how to process the data. Rules engine, I'm not sure what will be there inside, but it is all related to data processing. So this IoT rules engine will send data to Kinesis data streams. Okay, Kinesis data streams now has options to send that data to multiple places. Kinesis data analytics or multiple places, but all places should be where that data can be processed. For example, Kinesis data analytics, Kinesis data firehose, Lambda, or your own written in your HTTP website where you are processing that data stream. Okay, maybe some other programs also where you can process that data. So in this case, it is making use of data analytics for real-time data analytics and Kinesis data firehose to send the data for storage. So I said that when you want to deliver data to storage, you need to use data firehose. It is like firehose. From firehose, you deliver water to the building for extinguishing the fire. Okay, so Amazon S3 data once they sent, after some time they archived it to Glacier. Glacier means data is now cold. Okay, cold means it is archived. And then S3 data can be read through Athena. Athena is nothing but a service by AWS. So, and Athena can send that data to QuickSight. QuickSight is a BI tool by Amazon, but it is not as good as BI tool is which BI? Microsoft BI. What is that? I forgot the name. Okay.
Power BI.
So
Power BI. Power BI.
Power BI. Yes, yes, yes. Thank you, thank you.
W.
So Power BI, it is not as good as Power BI. Okay. And in the above flow, so Kinesis data analytics is taking the input and it is again creating the stream of analytical data, or it generated it analytics. For example, uh, whatever some basis, for example, temperature greater than this, temperature greater than that, or the records that we can ignore, those kind of all analytical data, it will send to data streams again in the form of data streams. So this data stream will be sent to Lambda. Lambda will process, and Lambda, what Lambda will process? Lambda will simply process that, okay, this, for example, if we are taking temperature, so it will give alerts like temperature of at this time is greater than desired value. For example, suppose this is scorching heat, we should switch on our AC if temperature is more than 45 degree. So this kind of notification Lambda will send. And Lambda, it's nothing but code written by us. SNS is nothing but our configuration, whom to send the email or whom to send the SMS. We have configured all those. Okay, and this is subscriber, publisher, subscriber. So it is against a topic. So something like that you can consider.
No,
Okay.
a question, one question. Lambda is sending what to SNS and SMS is doing what? SNS simple notification. SMS sending to.
Lambda is sending alert messages. For example, I program that okay, current temperature is greater than 45 degree. I create a string that temperature at this time is more than 45 degree. Whoever, Janardanan Prajapati, kindly switch on the AC. So the same string it will send to SNS. SNS will deliver that string as is to multiple mailboxes. Simple.
So Sudev, actually SNS is a notification service. I mean, we don't need to go in detail, but you need to configure it there. And whatever configurations you do, it will take care. Like which email box and other details there.
Yeah, understood that thing. Now, what Athena is doing?
Okay, Athena reads S3 data. You can use as a reader. Athena, you can fire SQL queries to Athena. Means you can open Athena, you can fire SQL queries to S3 data, and that you can send it to Amazon QuickSight, and QuickSight can then. So it is nothing but you can say kind of your SQL query writer.
Here, why are we using two streams, Amazon Kinesis data stream, initially and after analytics again?
Okay, whenever there is stream of data, you have to use some that streaming application. So one stream of data is coming directly from the sensor, and then another stream of data is coming from data analytics. That is why we use Kinesis data streams. So these data streams, if a stream is generated to be used by some processor, then we could have used after this data fire hose also. So we could have used after data firehose that data Kinesis data streams, and that data streams we should have sent to our own programmer or say our Lambda function. So wherever stream of data is getting generated to be processed or to be passed on to some programmer, we have to use data streams. As simple as that. Okay.
Yeah, to handle
so it
the
can be
time.
after. Yeah. It may not be real time. It can. Yeah. It will process in real time. As soon as it gets, it will pass on. Simple.
Exactly.
Okay. So it can be after KDA. It can be after KDF. Okay.
Okay. Yeah, Amazon Athena is it storing data or is it just reading from Amazon S3 or it reads? How does it read actually?
So Athena, you can consider Athena as a page where you can write SQL queries. Simple. You write SQL queries for S3, it gets you data, and QuickSight is defined as source to Athena tables. Okay, you can define Athena database and table where temporarily results are stored which are queried from S3, and those temporary results are being read by QuickSight, and QuickSight does its own analytics to show you the report or dashboard. Okay.
Okay.
Just one query. Yeah. What is the difference between data analytics and QuickSight? Data analytics also it does the data analytics, right? Which is sending as an intelligence, some kind of intelligence.
I did not get you data analytics. What about that?
What is the difference between data analytics and Amazon QuickSight?
Okay, QuickSight is BI tool. QuickSight is basically it will show you visualization tool.
Okay.
It is visualization. It will show you data in form of graph. Statistical tool, you can say. It will generate statistics. It will generate graphs. But data analytics is doing data analytics. You know what is data analytics, right? So this is visualization and this is data analytics. These two are entirely different.
Okay.
I mean, there is one course on Udemy. I think it's 8 to 10 hours. I will share the link or the name. And I gone through couple of times, and it's a very thoroughly given actually. Lot of all the services and all. I mean, whoever is interested, no, they can go in detail. That would also help in if you are pursuing any certification in AWS. And also for time being, if you can refer that to specific to these services, they have given the details along with some hands-on too. Let me share the link or the name of the course here.
So you are referring to Grunenberg or?
Yes, some Udemy. I just need to see because it's sometime, I think couple of years back I have done that course.
Okay,
Yeah,
okay.
because currently I'm
Okay.
working on Azure actually.
Okay, now in this case, they are trying to make use of a framework which is Apache Flink. All Apache tools are basically free, so Apache Flink they are using. So Apache Flink is basically some framework. Enables you to create applications in Java, Scala, Python to process and analyze streaming data. Okay. So they are saying that it will do all your what it is saying. It will take input, analyze the streaming data, and transform. It will do the transformation also. If filter is required, then filter. It will join data if it is required based on operators functions, and then send the output data to the target. So target can be any of these can be target. Okay, so it is taking data from input. Input is data streams. It will take the stream of data. It will do the transformation, any kind of transformation. It will filter or it will join multiple data points or multiple tables, and it will send that for storage. Okay. So
It's
all
like
the
a Java
programming,
program, right?
yeah,
Flink
it
is
has
something
written
like a
Java
Lambda
program.
only.
It has written Java program. Java, Scala, Python, or SQL. Basically,
So
it
this
included
resume is same
everything.
as Lambda only, right? Lambda also we can do the same thing.
Yeah, but Lambda is at smaller scale. Lambda in the background does not use Apache Spark or something. Lambda is purely based on AWS infrastructure or AWS framework. But this uses Apache framework, Apache Spark or Scala in the background.
Okay.
Janardanan, this KDA can send directly to S3.
Yes, you can
Okay.
look, you can find out what are the sources for things for KDA, where what it can send. So these all basically KDA can send data to these all.
Janardan, you are right. That's
Amazon
the same author, Grunenberg, Rand Grunenberg.
Grunenberg, because that is very famous course. Its
Yeah,
pace
it
is
was
very good.
exactly. It's 18 hours in total, but for time being, I mean, you can go through the entire course also, but otherwise, you can just target the topics, guys. But
Okay.
it's very nice.
Okay.
Yeah.
So
Yeah.
yeah, relational database is here in AWS. Relational database is basically any database can be there. It can be Oracle, MySQL, SQL Server, MariaDB, Presto, any database it can be. It can be even Redshift also. Amazon CloudWatch. CloudWatch is basically monitoring tool where it keeps on generating statistics. For example, who is consuming a lot of memory, who is not active at this time, any kind of all kinds of data generation it will do for monitoring purposes. You can make use of its data to generate various triggers, like who is consuming 5 MB of data per second, block all those users, stop their resources so that they are not able to do anything, any kind of processing. So that is CloudWatch. This is Kafka, you know it already. S3, you know it. Amazon Time Stream is basically in-memory database from Amazon. DynamoDB, I already explained. Okay, these are sinks. Sinks means target. So this is source, this is sink of data, and in the middle, who is taking input and generating output is Flink framework, which is nothing but a data transformer, which is taking the input, transforming the data, sending it to the source, sending it to target or sink. Okay. So there they have written Kinesis Data Analytics Studio. It is nothing but a UI where you can write your program. Just like you can say a Zeppelin notebook or any kind of notebook. Here also you can use that kind of user interface to do your programming. Okay, next is real-time telemetry data monitoring using Kafka. Kafka is used for real-time streaming. So you will get the data, do real-time streaming, and then you'll either show the result or you will just store the result. Simple. Okay. And when we say a lot of processing, either there is Elastic MapReduce or it is Apache Spark. Spark is in memory, Elastic MapReduce is disk based. There is this much difference. And EMR is very slow, obviously, because it is disk based processing, and it is redundant processing. Means for one thing, depending upon redundancy, it processes multiple times or it stores data multiple times, even if it is doing processing once. So Spark is much faster.
Just a minute. Go little bit up. Little bit. Yeah. Just now, do you hear it's, I think, come down below. Little bit down. Down. Where that aperture, no. Where the real-time processing line that, yeah, real-time processing with Amazon MSK and stream processing using Apache Spark. Stream processing only, it is a real-time only, no?
Yes, it is real-time.
Yeah. It's real-time. Stream processing is nothing but real-time. Yeah.
Yeah, Spark, wherever Spark is mentioned, it is a framework. So someone has to call that Spark thing, Spark programming. Someone, for example, MSK, Glue, or any other program, they have to program Spark. Otherwise, Spark will not do anything by itself. So Spark streaming.
Janardanan, can I add a little bit on Spark?
Please.
Yeah, yes. Yeah. So see, so Spark is nothing but a computing engine. Okay, so it is completely decoupled. I mean, you can use it. You can have your data stored anywhere. For example, in Amazon's storage, right, S3 or like, or even Azure Blob or anywhere, even local HDFS, anywhere. So Spark is just, its purpose is only to do computing. And on the normally, whatever computing it takes place, right, with Spark, you can achieve a very high 100 times computing because it is a parallel and as well as it's in-memory computing it does. I mean, I can definitely go in detail, but for this course, it will be too much.
So when you say computing, is it like minimum, maximum, average? Those are the computing?
No. You can write. See, in the Spark, right? You can write programs either in Python, Java, Scala, not Scala, Python, Scala, Java, or R. So when you write a program, right? So your program is supposed to say refer the data, okay, which is currently residing in say Amazon, I mean Azure's one of the blobs, right? Storage, and then you might see it's like the data is say 1 TB, like an example, okay. If you process through some PySpark framework, right, on the PySpark, so that will be too efficient actually. It's like which is currently, say example, just to give a simple rough example, if something RDB means like Oracle is taking say 10 hours, probably you can achieve the similar thing in few minutes using PySpark. That kind of, yeah.
What is this Kibana? Somewhere I saw, no? After that Kibana.
Sorry?
That Kibana, Amazon Kibana.
Oh, yeah. Janardanan, you can continue. You can continue.
What that line?
Yeah, Kibana is some tool that ELK is ELK. In ELK there is Kibana. Yeah.
What for that?
Is it mentioned here in this
No,
page, in this?
Where I saw no previous line only where I showed you no the real time that there.
Okay. Yeah, Kibana, I'm not sure. I need to read. Actually, I forgot. I read it 2 years back. I need to read it, what it is used for, but it is from ELK only.
Yeah. So today mostly you can focus on the tools like the Spark, right, which is also real time and batch. They have some libraries that you can refer to process the real time data. And Kafka also. I mean, you don't need to go to other AWS services, but just to get familiar with these services which are related to streaming. Yeah. Yeah. No, I'm saying this is good only, but I'm saying, yeah, he was asking some other service, right? So, Janardanan, you can continue. This is very good, actually. You are giving overview on all the services. You can continue. I'm just saying, for Sudhir, if you try to go in detail, you might get confused.
Okay. Okay, I just wanted to explain at least once guarantee. Delivering at least once, actually, it is related to message, delivering messages. So at least once message can be delivered more than once, but at least once it will get delivered. Another is exactly once delivery, and that follows the FIFO also. Means message order is also kept intact, and there actually it becomes slow because there is ordering of the messages based on time. Ordering, why it is important? Because since our framework uses parallel processing, so messages come in multiple, uh, you can say, parallel processors, and those all processors will, processor by processor, I mean, whoever is uh, reading data from the queue. So when at multiple queues are there, then in any queue it can go, and in that order is lost. So to maintain that order, that first in first out kind of thing has to be there. So it becomes little bit slow when exactly once delivery is required, and at least once delivery. So in this case, what happens? Multiple message processors can process the same message, and in that sense, one message gets delivered multiple times. For example, you can get one email of message like temperature now is more than 45 degree 2-3 times. At one point of time it will come, obviously, because there is not much delay between the processors. Yeah, this is Elasticsearch service with Kibana. This I did not read it. Kibana is data visualization, it is saying. So Kibana is also like a quick site, and Elasticsearch, it is for search. Okay, searching, how it does, I did not go through in details. I managed to finish it. Okay. I hope I in the call.
Products. Yeah, a lot of products to study. Yeah, thanks, I think. Yogesh and Janardanan, I think it's good.
Yeah, can someone share me the answer of that SQL related question?
Yeah, Janardanan already explaining, when he explained very well, that really helps everyone. Yeah.
Thank you for your interest. Thank you. Yeah.
No, it's very good actually. Yeah, to get started, no, kickstart. That's nice. Yeah. Yeah, we can. I mean, I'm also, I mean, if Janardanan stage is good because looks like he has a very good understanding. So if we can continue and see if anyone has any other queries like that, no?
Okay. Yeah.
Because I'm, yeah, yeah, I mean, please, like ask questions. Let's see how we can discuss and answer.
Okay. From my side, that SQL related question answer, if you can explain if someone knows it.
What was the question? I mean, let me just
Okay.
see.
Okay.
I joined late. Yeah.
Yeah. I'll explain. Where is my document?
But again, I'm not working in AWS. Okay, based on my knowledge when I gone through that course uh, earlier, I will try.
Streaming data solutions fund. Okay. Where is that question paper? Okay, if you open that assignment.
Assignment, okay.
So do you want to do we go through all the questions or like specific questions only? Just quickly.
So,
But I see when I gone through the questions, no, what I felt the first impression, mostly the theoretical questions. I think you're talking about the fourth question. What are the ways by which streaming data can be queried through?
yes.
Okay.
Yes, fourth question, 0.75, yes.
Okay. Well, I know Athena, like we query, right, to the data stored in S3. But for this streaming data,
But it is streaming data.
yeah, streaming data, I need to
to
recheck. Yeah.
query S3 data, you can use 4 things. One
Correct.
is S3 select, Athena is there,
Yeah.
and Redshift Spectrum is there.
Yeah.
And one more thing is there. 4 things maximum can be used for querying S3.
Yeah.
So
But
we
yeah, I mean, we
basically
can
use we basically use a large set of S3 data, which is 5 GB or 10 GB data, put it to Athena because it can't fit into any of the RDBMS. So that's what we use Athena. So a big data. So because behind the screen it use Hive, so which is a big data concept.
yeah.
Okay, so for the timing, I need answer to that question. If you want to query streaming data, how you will use SQL?
I knew actually, but I need to little bit go over sometime, and maybe I can come back.
Yeah,
but if
please.
somebody knows, confirm. Yeah, but
Yeah,
somebody knows. Yeah.
Yeah, later also if
Couple
you.
options. So one is Kinesis data analytics is there, right?
Amazon Kinesis data analysis.
Correct.
Then in that case, Firehose, but SQL, using SQL, does that use SQL?
We can frame a data analytics inside Kinesis to store the streaming data in a SQL format, and you can view and query that. So it's an in-between temporary memory, in-memory SQL.
Okay.
Yeah, I heard earlier about this Amazon Kinesis data analytics. That is something we can use to query the stream data.
Yes.
How?
Yes.
Probably I will go over once, and maybe next time try to give some kind of a demo if possible. I mean, I don't know whether we can create a service, but up to the extent to explain the concept, we'll try for that.
So basically, in the Kinesis stream, we have to frame a structure, data structure. So that data structure would be coming in here as a table view, and we can start using our SQL commands for analyzing.
But again, I mean, just sideline of this one. I mean, if anybody is interested in Databricks or Spark, probably I can do some demo also. Probably it is not immediately related to this assignment. Maybe sometime later also we can do. Just a thought that I thought to share.
Sure, Yogesh. Yeah, you can.
So in Databricks, what you are using, Delta Lake?
Yeah, we have the data stored in Azure blobs, okay, and then we have the Databricks. We have clusters, and then we use mostly delta tables rather than Parquet or CSVs. Not, but
Okay.
CSVs are very.
Actually, Databricks internal storage is only Parquet files internally. It stores Parquet only.
Yeah.
So there are two types. One thing is if you want to maintain historical data also, then you use delta tables. You call it as delta table, means
But
there is a
instead,
flag.
yeah.
Otherwise, if you do not want to store history, you want to overwrite or add, then you use Parquet format as is in Databricks.
Yeah. So the delta table is easy. I think you can even update also, right? Make manipulations.
Yes, we
Yeah.
can update also, right?
And once you know like Python, no, you can use PySpark. I mean Python to write Spark programs, and you can run those on the Databricks cluster. So your data is stored somewhere in like decoupled anywhere, and just your Python program will run against that data. It just the job of the Spark is just to execute your logic, right? It is nothing related to data there.
Yeah, so in my case, I can explain what I'm doing, use case of Databricks. What I'm doing, I have a customer table. Means it is all about customer records. Okay, so each attribute of the customer is stored in a separate file. Okay, for example, customer cohort data or customer income band, this way. So there is customer ID and then income band. So each kind of such attribute with customer ID stored in a separate file. So what I'm doing, I'm writing separate files of program in PySpark and using data frames obviously, and storing that data to separate files.
Okay.
Using that PySpark programming itself, and that is all happening in Databricks and Delta Lake.
Okay, I mean the
in
kind
AWS
of
environment.
What
Oh,
is
you
the
have a
usage of
AWS.
splitting each attribute?
Please say again.
No, you mentioned you are keeping each attribute in one file, right?
Yes,
So why we are doing that?
because I do not I'm building attributes separately for customer. There are some basic attributes. For that, there is a relational table. Apart from that, whatever attributes I'm deriving, for example, customer income band, I manage data from somewhere, and now I have the customer income band information. Then I'm adding that separately. That this is customer ID and this is customer's income band. Similarly, customer spend. What is the monthly expenditure by customer from our store, our retail store, how much user is uh, spending daily or monthly. So similarly, all kind of data we are generating and storing separately.
Is it because of the
Because
cyber
we are
issues or?
getting data separately.
Okay.
So I think
Yes,
business
it is
business
okay.
entities, right? Different
Okay,
entities, right?
Yeah, different files. This S3 files you can say, or Delta Lake table you can say. So yes, I can explain it the other way. Now there is a repository, Data Lake repository, which is immutable, means you cannot change its data. Because why you cannot change data? Because data is not stored in blocks. Whenever there is block, you see disk also is organized in blocks. Whenever there is block, then only you can write the data or change the data. But when it is object stored, means you can put your objects, every file, every data is stored in objects. then you cannot make changes to that data. Okay, so anywhere there is S3 like storage or data lake like storage, there if you want to make changes, you need this Databricks application or Databricks framework or whatever, Databricks data lake tables. It shows you data in the form of blocks, and then you are able to modify that data. Means you can insert, you can manipulate.
Yeah.
So that is how, and since I'm getting data separately, so I do not want to increase the timing of my existing record updates. So better I will write separately rather than embedding in one record. Anyway, I have to use separate files.
What we do know, our programs, I mean, the Python programs that we have, they refer the different data sources, like you can say different entities, right? But the execution, it happens on the Databricks. So when the job kicks off, it will export the data from my local any changes, right, to the Databricks
Right.
cluster, and then there in the DBFS again.
Yes.
Databricks has its own file system, DBFS, right?
Right.
And then
Right.
the cluster is nothing but a computation engine. It will execute that. I mean, the
Yeah.
kind of cluster we use is like very heavy. I mean, it's like the memory itself is like, I think, 2 to 3 TB. It is
Yes.
quite huge, yeah.
So once it gets the data,
Yeah.
it uses its own file system, and then it has to replace entire table. It has no other option.
I mean, let me see. I mean,
It may not be entire table because the table can be stored at multiple places. So that one partition will be actually, because we can do partitioning of the file also in Databricks.
Yeah, PySpark, no, PySpark you can use and you can decide how many partitions you want.
Right.
And default, whatever configuration of PySpark, it will create those one. And again, the Spark, right? The Spark is what it does, no? It does a lazy evaluation. I mean, there's a concept called lazy evaluation.
Lazy evaluation is there, yes.
Yeah. That is the like main feature of Spark. So guys, like
lazy evaluation means
Mhm.
it will not compute until that thing is required somewhere.
Exactly. No, I mean, I think we need to give some example to the audience. They will know. So guys, like say, if I have a query, right? I'm querying a table, customer table, okay? It has some data. I will just say select like 10 columns from customer, and I'm storing in data frame, say data frame 1. So when you execute that query, it will not immediately give you the result. It will just keep it in memory. Then what you can do, you want to say apply another filter, say where customer city equal to Mumbai example, okay? That's it. So another data frame 2 equal to data frame 1 where the customer city equal to Mumbai. Again, it will not do anything. It will just keep your query, appending, but it will not execute. So likewise, you can keep on adding the things. And when you say, right, like some action, like a print or show, right, that kind of action when you do, then it will run from the start actually. It will run from the start, it will run the customer table, it will filter each level. So that is kind of a lazy evaluation it is called.
I can give another example.
Yeah.
Should I? For example, layman's language. So suppose I'm telling I have written a program to calculate the factorial. Okay. And I said the application that, okay, calculate factorial for 10, 15, 20, or say 10 numbers. But that program will not calculate the factorial even if I have told, unless that factorial is actually used somewhere. Because even if it calculates, there is no use if it is not used somewhere, right? So whenever it is used, at that time it will run the program to calculate the factorial of that particular number only. So that is lazy evaluation, right? Am I right?
Yeah. Whenever there are some set of actions, when it is called, then only it will run. Until that time, it will keep chaining and wait for that action. And everything happens in memory actually. So that's the reason the computation is much faster, because the kind of cluster we define, right? Again, it depends on the cluster which you define. Again, you can set up a cluster with different, right? The nodes, the higher the node, the more the nodes, you will have to pay more to the Databricks. It's again a similar cloud concept. Yes.
Yeah, memory is not infinite, so to acquire more and more memory, you need more and more compute power. When we say compute, you can consider that extra machine is added to your processing power in the background, and you have to pay for that.
And again, guys, I have shared another, I think, link also in the chat about basics of PySpark. I mean, again, it is when you find time, go through that. That will be really interesting.
Okay, good.
Yeah. I mean, these are the basic courses. I mean, for someone who wants to know PySpark, the Databricks is just one tool where you can execute your PySpark programs. It's not like it's just one of the platform Databricks came up with, where you can leverage the high computing power, cloud computing power. I'm just trying to log in here. I mean, I thought of login and just show you how it looks.
So Spark will also have SQL queries.
Yeah. In Spark, no, you can write normal SQL queries also, like normal, like RDBMS queries too. Literally RDBMS queries.
Okay.
Something I will next, maybe in the demo sometime, no, I will try to come up with some, dummy data or something I will try to show. So if you know the SQL, right, that you use normally like against Oracle, so exactly same SQL also you can use here also. You just have to do this couple of steps before, and then you can fully use the existing SQL.
So it's like we can use Spark to connect to any RDB.
Any storage. Not only like any cloud, Google Cloud, Azure. See, it has multiple. The way you can authenticate, right, where your data is stored, and once it connects the data, then you just have to run your logic, right, computation on the data that you are connecting with. It is completely decoupled. Or if you want, right, what you can do, you can set up HDFS on your local machine, just for your playground, and then you can install or put some data. You can also install PySpark and you can play around it. Like it is really interesting. On the local machine, you might not see that kind of a speed, but in actual like industry projects or programs, when you have to process TBs of data, then you will see how it is very useful. And again, PySpark, it has normally what you do is you can do, it also provides the ways that you can process the streaming data. So that's how we started this topic, right? PySpark. So it can process the streaming data as well. And then there are some machine learning also. There are libraries for ML ops as well.
Yogesh, have you set it up PySpark with the multiple cluster by yourself in your local machine? I was trying to do that actually.
Oh, you cannot do, right? Local machine is single machine, right? Multiple clusters.
No, I have two machines, so I have a laptop and a desktop, so I just want to connect the cluster of two.
I have to check how we can do that.
Okay.
Yeah. Otherwise, no, the best thing, just you can set up a cluster on cloud.
Okay.
You can mention how many how many worker nodes you want. Driver will be only one. It's like master slave architecture, okay, for everyone. So you can mention how many workers you want, and it will create that Spark cluster for you. Or I'm just trying to log in actually. If I could log in, I don't remember the password, but I'm just trying to log in. If I could, I can log in and share you the interface of Databricks.
Meanwhile, can I ask a
query.
question regarding this assignment last part?
Last part, yeah.
Yeah.
Let's see.
In the last part, do we like need to write some codes or general design document type where we will mention, okay, for this data ingestion we have selected this service, for data processing we have selected this service, and then write make a diagram how it is mentioned for scenario, example scenario in the white paper. We have to do it in the similar way, or we have to write some codes.
So my guess is first we should make a diagram. Next we should write what is the purpose of each query, each
Exactly.
service, and
Uh,
and then just the flow, just one paragraph or two paragraph description how services are integrated to each other.
So how exactly how it is shown in the given scenario 1, 2, 3? Exactly a
Right.
diagram,
I
then the
guess so.
services, and then how it is interconnected. No codes, nothing at all.
No,
That's what I
not
understood.
required.
That's what I understood. Yeah.
Not required.
Okay. Yeah, exactly. Same. Okay. Just
Even I
wanted to
think
check
so.
on.
Yeah. Even if I think so,
Yeah.
because I mean, for someone who is completely new, right, it is very difficult to practically
Correct.
build that.
Right. Yeah.
So better.
And
In
and
like
we can
10
we
days.
can
Yeah.
Yes.
we can objectively describe, for example, ingested streaming database to be stored for 7 days. Can
Yeah.
AWS streaming, what Kinesis data stream can be used.
KDA.
Raw
Yeah.
streaming data be stored so that it can be fed to other AWS services. So raw streaming data. So again, Kinesis data streams can be used. Scalar to be used as language for data enrichment application. So here
That
Glue can be
AWS
used
Lambda
because
also can be used.
Glue can be used, or Lambda also can be used, because Glue
Yeah.
internally can use Scala, or Python it can use. There is option actually. And then data address to be queried using SQL. Athena can be used, Redshift can be used here. Has to have capabilities to search within streaming and this data. Elasticsearch can be used.
That search, Elasticsearch, yes.
Yeah, alert to be sent to the consumers when certain criteria is
SNS.
met. Yeah, Lambda with SNS can be used, because Lambda will
Yes.
process all those
Lambda will
criteria, and
process,
SNS
and
will
then SNS
publish
will
it.
send the email.
Yeah, right. So this way, objectively, we can just describe, and
Exactly.
we can make a diagram. That's it.
Yes.
How about the second one, what
Yes.
you mentioned? The Scala language can be used in Lambda, and then the other one you were mentioning?
Glue.
Glue. AWS Glue, there is option whether you want to use Scala or you want to use Python.
The raw streaming data into other AWS services, it is Firehouse?
Raw streaming, Kafka can be used, or AWS data streams can be used, right?
Okay. Okay, so other AWS service is not Firehouse, or it is Kafka
Okay,
only? Or it
Kafka, does it store? No. Yeah,
No. Kafka
KDS.
stores it. Yeah, Kafka stores the messages. Actually, I think we have to give some settings, because until the
Yeah, then
subscribers, right? They
yeah,
take the
then
messages.
Kafka stores messages, means it is storing raw data. Same way, KDS also stores raw data. But in Kafka, do we need to store for 7 days? Kafka does it store, but this KDS stores for 1 to 365 days. From one,
No, we
minimum
have
24 hours.
Kafka to store, I think.
So KDF is just for transfer only. There is no storage. That's why we are rejecting it, is it?
No,
Kinetic
KDS
data.
can store from 1 to 365 days.
I'm referring to KDF. Can I say data Firehouse?
No, data firehose doesn't store it.
So
And
it's
moreover,
still
data firehose only delivers to the storage location.
Firehose will deliver to storage, yes, S3 or
there is
Yes,
no
though
storage.
it does the transformation, yeah.
Oh,
But we
the
need to
first
feed
part,
it
right?
to other services. Mhm.
Sorry, just one thing. So for the first question, right, they were asking what is the component used for process data delivery. So basically, like after processing the data, it can be Lambda or it can be any other thing, right? So what is used for process data delivery? Is it referring to the
Delivery.
notification?
For delivery, you need to use firehose, right?
Okay, it is just a delivery. There is no storage over here. So
So
storage
delivery means
delivering
you
to
need to
the.
deliver to storage location.
Okay, okay.
Which question you are saying?
This is the first question. First question.
D part. Yes, data delivery. Finally, you are storing it, right?
So the enrichment and processing, it's all from Lambda only.
Yes, Glue can also enrich. There are multiple services for the same thing. Kafka can also do the same thing, right?
Kafka can also enrich.
When I have the data bricks is ready, yeah. In case if you want, I can just high level I can walk through. Or if you want later also, it is also.
Meeting will end in 9 minutes. There is message.
I think better to do a different session.
Okay.
Yeah, different session will be better actually.
Detailed
And
different session, yes.
yeah, and I'll request you please explain in layman's language whenever you explain, so that at least I can understand.
No, I will definitely try as if you do not have a complete idea. Probably I will start with some Spark basics and try. But I would recommend when we try to set up such a demo, I would recommend to go through this course that will help you to understand the basic Spark concepts. I mean, I can show you here actually how you can create a cluster, how you can store the data, how you can run the queries, those things. Yeah.
Okay.
How different is this with Snowflake?
I think Snowflake is also another cloud, right? A cloud type where you can store the data and do processing, like AWS.
Yeah.
Azure.
Redshift, but Snowflake is very popular right now. Yeah.
Yeah. See, these
Snowflake
are like
is again data warehousing solution, right? Just like AWS Redshift.
Yeah. Mostly, every you take any cloud provider, take AWS or Azure or Google Cloud. They have almost all types of similar services. The names are different, or the way they are providing little different. If you know one cloud service like AWS, it won't be that difficult for Azure or Google Cloud. Only the way they do it or different, the names are different. But the basics will remain.
All the concepts are same. You are right.
Yeah, concepts. Example you take. Let's take storage, right? So AWS provides, I think, 5 to 6 different storage, right? S3 and I think more cold storage and all, right? Glacier. The way you want it stores, it gives an option which storage service you want. You want S3 or that will be more costly, right? But similarly, Azure also have some like ADLS, right? Azure Data Lake Storage. So like for each and every service in one cloud, it's a similar thing. You will find it in another one.
Yeah, and entire data life cycle will be the same. For example, in AWS, there is S3 standard storage, S3 infrequent storage, S3 glacier, S3 snowball. Same thing you will find in some other names, with some other names in Azure or GCP.
Yeah. See, in AWS, I told you, right, the storage services. So I think there are 5 to 6 different types are there. Depending on what type of service you want, I mean, storage you want, you can prefer that. Say you want, when you want us to store the data, you also want to get it immediately. Then you can prefer S3, and that is little more costly. But
S3 standard storage.
S3 standard, exactly. And then I think S3 infrequent something, right? So if you want your data to be stored, but you think that okay, you don't need the data that much frequently, and you are okay to, I think, wait for an hour or two for that too. So that kind of thing you can go with the infrequent. The price will be little less.
No,
Yes.
in infrequent also, it will give you data within seconds. But
Yeah.
the other forms like AWS
Yeah.
Glacier,
Yeah, then it takes an
that
hour.
in Glacier there are categorizations. If you want data in 3 to 5 minutes, then there
Yeah.
is something actually. And then lowest cost storage, you have to wait for 24 hours to get your results.
Yeah. Yeah, it depends on what type of your need is. I mean, and if you are like fine, you do not need it immediately. You can go with the lower cost service that way. So they are giving multiple options.
Yeah, and that reason for those options are the kind of storage device they use. For example, for quick access, they will disk fast. They will use SSD. Then further, may use hard disk of other type. Then they will use tape drive. So that way, cheaper hardware they will use.
Yeah. So I think we have this Spark topic in BDS sometime later. I don't know where. I think post midterm or I don't know pre-midterm. Maybe that time we can have a kind of a demo if you guys want. Yeah.
Yeah, and that will be very helpful because Spark is required everywhere now. For us, it is most important.
I would say Spark is one of the popular now languages. Like if you know Python, yeah, just let me. I think 3-4 days back. I mean, at least no. I'll try to put some kind of a data to show you some things here. See now I have in my last semester I had right diamond assignment for ML. So I have this data set and I was playing around with something. I think I was showing something to someone. But I will try to keep it ready, some commands. So we don't need more time, right? I will try to show as much as more in the given time window. Yeah. And I already pinged the link to the Udemy course. I think it's 5-6 hours. And it is good. Sorry? Oh, 18. Oh, first 18 hours is for AWS. See, that is I told you, no, in AWS there are many services. I mean, if you want, you can go through that full course and to understand, or you can just see the glossary and see target the streaming services for our assignment now. But that AWS course, right? It is very good and very helpful. Again, until you do some hands-on, it is hard to understand. It looks like you understand, I mean, understood, but when you try to do something, it's like again, completely blank. Yeah. Yeah, Apache Spark is good. I think when you have time, right, we can have this demo. You can. I have shared the second link, right? I think did I share second link or no? No. Probably. Okay. Yeah. Yeah. That is also a good one. That will give you. Yeah, that will give you a little overview of Spark. What exactly is Spark architecture and all. Then what? Mhm. Sorry, Manoj, can you say again a little loud?